On November 1st, 2025, after 33 years of planning and 20 years of construction, Egypt finally opened the world's largest archaeological museum in a ceremony that lit up the night sky above the pyramids themselves. This wasn't just delayed, it survived a revolution, a pandemic, and funding crises that would have ended most projects. Today, we're exploring the Grand Egyptian Museum, its $1.2 billion construction journey, and the engineering that protects over 100,000 priceless artifacts from earthquakes in the scorching desert sun. So let's start with scale. The Grand Egyptian Museum isn't just big, it's colossal. This mega project covers 500,000 square meters. With 81,000 square meters dedicated to exhibition space, it officially holds the title of the world's largest museum dedicated to a single civilization. To put this in perspective, the famous Louvre in Paris, with its palace, courtyards, and gardens, spans just 240,000 square meters, less than half the size of the Gem. This massive footprint houses over 100,000 artifacts spanning 7,000 years of Egyptian civilization. But getting to this point was anything but smooth. First proposed in 1992, the project launched an international architectural competition in 2002 that attracted over 1,500 entries from 82 countries, with Irish firm Hennigan Peng Architects winning in 2003. Construction officially began in 2005, only to be delayed by revolution, funding gaps, and a global pandemic. After 33 years, it's finally opening in 2025, exactly 103 years after Tutankhamun's tomb was discovered. The opening ceremony alone, held on November 1st, reveals how important this project really is. A spectacular international event. Egyptian President Abdel Fattah el-Sisi welcomed dignitaries from over 80 countries. The outdoor ceremony was staged on a specially constructed platform next to the museum's impressive 110-ton suspended obelisk. An extraordinary display of lasers and fireworks illuminated the 4,500-year-old Giza pyramids themselves, with hundreds of drones creating light shows depicting ancient Egyptian gods like Isis and Osiris. But what makes this opening truly historic is that for the first time since British archaeologist Howard Carter's discovery in 1922, all 5,398 artifacts from King Tutankhamun's tomb are now displayed together in one place. The Tutankhamun Gallery spans 7,500 square meters and was designed by Atelier Bruckner as an immersive spatial narrative guiding visitors through the young pharaoh's life, death, and afterlife. More than 3,000 of these objects have never been publicly exhibited before. Among these treasures are Tutankhamun's iconic golden death mask weighing nearly 11 kilograms of solid gold, his gilded coffin, bejeweled ceremonial throne, golden sandals, royal beds, and an iron dagger believed to have been forged from meteorite metal. The artifacts needed a home, and the location chosen was no accident. The museum's location is strategically positioned on the Giza Plateau, approximately 2 kilometers from the Giza Pyramid Complex. The building's designed by Irish firm Hennigan Peng Architects organizes the structure through visual and spatial axes aligned with all 3 pyramids. Visitors move along a central grand staircase, connecting the entrance with the main exhibition level, offering framed views toward the Giza monuments through a full-height glass wall, literally connecting 7,000 years of civilization in one panoramic view. Egypt's tourism minister, Sharif Fathi, projects the museum will attract approximately 5 million visitors annually, positioning it among the world's most visited museums alongside the Louvre, 8.7 million, British Museum, 6.5 million, and Metropolitan Museum of Art, 5.7 million. The museum is expected to create tens of thousands of jobs and significantly boost Egypt's tourism sector, which contributes about 8% of the country's GDP. The Grand Egyptian Museum is far more than aesthetic. It's a sophisticated engineering response to one of the harshest environments on Earth. The building's massing follows the desert's natural contours, ensuring it remains visually subordinate to the ancient pyramids on the horizon, while still commanding attention as a modern architectural landmark. A translucent stone facade composed of locally sourced alabaster defines the building's desert-facing elevation, creating a luminous threshold that filters daylight and responds to the natural topography. This wasn't just an artistic choice. It's a thermal management strategy that reduces solar heat gain while maintaining natural illumination. Upon entering, visitors encounter the 6-story Grand Hall, where the 82-ton, 3,200-year-old statue of Ramses II stands guard beneath a roof that admits carefully controlled, diffused sunlight. The engineering challenge of positioning this colossal statue required the museum to be literally built around it. The The statue was moved to the site in 2006, 4 years before major construction began. The museum's centerpiece is its 148-step grand staircase, which isn't just circulation. It's a carefully designed journey through Egyptian history. As visitors ascend, they pass dozens of statues of Egypt's most famous pharaohs and queens, each positioned to tell part of the story of this civilization's 7,000-year timeline. At the top, visitors are rewarded with a perfectly framed panoramic view of the 4,600-year-old Pyramids of Giza through a full-height glass wall. The staircase's vertical rise was precisely engineered so that the museum's top level aligns with the pyramid plateau, creating visual continuity between ancient and modern Egypt. Plans are underway to eventually build a walkway connecting the museum directly to the pyramids. And while that view is stunning, what's underneath the museum might be even more impressive. Because just like the ancient pyramids it faces, the Grand Egyptian Museum had to be built to last, especially in a region that's no stranger to earthquakes. Egypt sits in a seismically active zone, making earthquake protection critical for a museum housing irreplaceable artifacts. The GM employs a sophisticated base isolation system, essentially giant shock absorbers for the building. This technology allows the building's foundation to move independently from the superstructure during seismic events, dramatically reducing the forces transmitted to the artifacts inside. Base isolation systems use layers of rubber bearings and sliding mechanisms that can shift horizontally by up to 30 centimeters during an earthquake, absorbing the energy that would otherwise damage the structure and its contents. For a museum protecting 100,000 artifacts, many over 3,000 years old, this technology is literally priceless insurance. But earthquakes aren't the only threat to ancient artifacts. Extreme heat, UV radiation, and desert dust can be just as damaging over time. That's why the Grand Egyptian Museum wasn't just engineered to be safe, it was engineered to be smart. While the museum's triangular glass facade may visually echo the pyramids, it's primarily a masterpiece of sustainable engineering. The angled facade is covered in high-performance glass that floods the interior with natural light while blocking harmful UV radiation and reducing thermal heat gain. Even when exterior temperatures soar to 65 degrees Celsius, 150 degrees Fahrenheit in the desert sun, the museum maintains a comfortable temperature inside of 23 degrees Celsius, 73 degrees Fahrenheit. This isn't achieved through brute force air conditioning. The building's thermal envelope, orientation, and natural ventilation strategies minimize cooling loads before mechanical systems even engage. But the most striking sustainability feature is found at the very top. The museum's roof is covered with extensive solar panel installations that generate renewable energy while paying tribute to Egypt's natural heritage. These panels are arranged in a pattern that mimics the Nile River Delta, adding cultural significance to a purely functional system. The solar installation, combined with energy-efficient LED lighting and smart building management systems, results in energy savings equivalent to removing over 400 gasoline-powered vehicles from Cairo's streets annually. But the sustainability story doesn't stop at the roof. Step outside, and you'll find a landscape designed to echo the journey of the Nile itself. Crafted by the renowned firm West 8, the museum's grounds feature a meandering path that mimics the river's flow, weaving through shaded groves of native plants, date palms, and reflective water basins. These outdoor spaces, ranging from a formal plaza to a tranquil palm grove, don't just frame the architecture, they ground it in Egypt's geography and ecological heritage. It's not just beautiful either. The design uses water-saving irrigation systems and entirely native flora, helping to preserve over 63 million liters of Nile River water each year. Even the granite and limestone paving stones were sourced locally, anchoring the project in its physical and cultural landscape. The result is a museum that doesn't just showcase history, it's rooted in it. Despite being home to some of the oldest artifacts on Earth, the Grand Egyptian Museum is also one of the most technologically advanced cultural buildings ever constructed. To bring it all together, the team relied on Building Information Modeling, or BIM. Using Autodesk's Revit and BIM 360, they created a fully integrated 3D model of the museum, down to every duct, pipe, and power cable. This wasn't just a design visualization tool, it was a live, collaborative construction blueprint used to detect clashes, update plans in real time, and keep the $1.2 billion project coordinated across a decade of delays. And that's just the digital backbone. Inside, the museum houses the largest conservation facility in the Middle East. It spans 7,000 square meters and includes 17 specialized labs focused on everything from gold to mummies to ancient textiles. These labs use tools you'd expect in a scientific research facility: Electron microscopes, spectrometers, infrared scanners, and even microbiology stations that monitor the invisible organisms threatening to degrade priceless relics. With these technologies, curators aren't just repairing the past, they're future-proofing it. The display cases themselves are engineering feats. Designed by the Italian-Spanish firm Gopion, they regulate humidity, lighting, and air pressure for each individual artifact, creating tailor-made environments that preserve everything from papyrus scrolls to wooden statues. But some of the most powerful experiences here don't come from the physical objects alone. Holographic projections bring ancient craftsmanship to life, revealing hidden layers in iconic artifacts like Tutankhamun's golden mask, and a VR experience developed by Atlantic Productions lets visitors step inside the Boy King's tomb exactly as Howard Carter saw it in 1922. It's the past, reimagined through the lens of immersive tech. And while it all looks effortless on the surface, everything behind the scenes is carefully controlled. Environmental systems constantly adjust temperature, humidity, and air quality with precision. If something drifts out of range, even by a fraction, alerts go out immediately. After more than 30 years and $1.2 billion, the Grand Egyptian Museum is finally complete. It's the largest archaeological museum on Earth, and one of the most ambitious cultural megaprojects ever built. From earthquake-resistant foundations to solar-powered systems, and from holograms to the full Tutankhamun collection, this is where ancient history meets modern engineering. So, what do you think? Is it worth a trip to Egypt? Let us know in the comments. Thanks for watching, and if you enjoyed this, hit like and subscribe. Mega Builds covers the world's most incredible infrastructure, and we've got more coming soon.